Okay, guys, looking at the third section in Unit 8, we're going to be looking at 0 and negative exponents. Looking at the example we have here, we have 2 raised to a bunch of different powers here, ranging from 2 to the 5th all the way to 2 to the negative 4th power. So we're going to do the same thing here. We're going to write it as repeated multiplication and simplify it to start. So 2 to the 5th is 2 times itself 5 times to give us 32. 2 to the 4th is 2 times itself 4 times to give us 16. 2 cubed, or 2 to the 3rd, is 2 times itself 3 times to give us 8. 2 squared, or 2 to the 2nd, will give us 4, and 2 to the 1st is just 2, so it simplifies as 2. Now we're looking at 2 to the 0, and we're not really sure what to do here. But if we look at a pattern here, we notice that to get from 32 to 16, or in other words, 2 to the 5th to 2 to the 4th, we can divide our simplified answer by 2 to get from 32 to 16. Same thing from 16 to 8, we can divide it by 2. And from 8 to 4, we can divide it by 2. And from 4 to 2, guess what? We can divide it by 2. So to get from 2 to the 1st to 2 to the 0 power, we can probably just divide 2 by 2, and that'll give us 1. So 2 to the 0 power is 1. Now 2 to the negative 1, we can just divide 1, our previous simplified answer, by 2 to give us 1/2, and so on and so forth. So 1/2 divided by 2 would give us 1/4, and 1/4 divided by 2 would give us 1/8, and 1/8 divided by 2 give us 1/16. So we notice the pattern here in our simplified answers, and we can apply that rule all the way down to 2 to the negative 4th. So now we have all of our simplified answers all the way ranging from 2 to the negative 4th power to 2 to the 5th power. So let's summarize the pattern we observed. As the exponent decreases by 1, the power is divided by 2. In conclusion, if an exponent tells us how many times to multiply by the base, a negative exponent tells us how many times to divide by the base. Divide by the base. Okay? Take some time to write that down if you need to. Okay, so looking at the 0 exponent, a to the 0 power, this is our general rule. A can represent a number, right? A to the 0 power equals 1, as long as a does not equal 0. So a to the 0 power equals 1, as long as a doesn't equal 0. A to the negative n power will give us 1 over a to the n. A to the negative n power will give us 1 over a to the n. Now 1 over a to the negative n power will give us just a to the n, because they kind of reverse themselves. 1 over a to the negative n power will give us a to the n. And that's our rules for negative exponents. So there's our 2 generalized rules for 0 exponents and negative exponents. So now we're going to simplify the expression, and we're going to write our answer using positive exponents. So 5 to the 0 power, we know, is 1. 3 to the negative 1 power is 1/3, right? A to the negative n is 1 over a to the n. 3 to the 1st is just 3, so 1 over 3. Now we have xy cubed all to the 0 power. Xy cubed all to the 0 power. And that just gives us 1, because we know that anything raised to the 0 power is 1. So looking at these ones, we have 12x to the negative 5th, y to the 0. We have 12 times 1 over x to the 5th, because x to the negative 5th is the same as 1 over x to the 5th, times y to the 0, which is 1. So this gives us 12 over x to the 5th as our simplified answer. 12 over x to the 5th as our simplified answer. All we did there was multiply everything we had together. 12 times 1 over x to the 5th, since it's all multiplication, we can combine them. Yeah, we can just work left to right if we remember our order of operations. So 12 times 1 over x to the 5th is 12 over x to the 5th. And then that times 1 is just 12 over x to the 5th. So looking at number 5, we have 28x to the 5th over 7x to the 12th. So 4x to the 5th minus 12. What we're doing here is we divided 28 by 7 to give us 4. And x to the 5 minus 12 power, we know from our previous lessons when dividing exponent powers. So 28 divided by 7 is where we're getting the 4. And x to the 5 minus 12th power. And 5 minus 12 is negative 7. So our final answer would be 4x to the negative 7th power. So we get the 4 from dividing 28 by 7. And then knowing our rules of dividing exponents, we will take x to the 5 minus 12 power. Okay, so looking at the next one, we have 16y to the 5th x to the 6th all over 8y to the 5th x cubed. So look, going back to number 5, we can reduce that even more, right? Because it's a negative exponent. Sorry about that. We can get 4 over x to the 7th power, right? Because it's a negative exponent. 4 over x to the 7th. Sorry about that. Now we can move on to 6. Looking at 6, we have 2y to the 5 minus 5, x to the 6 minus 3. So what we're doing here is we get the 2 from dividing 16 by 8, and y to the 5 minus 5, again, using our rules for dividing exponents, since they're the same base, we keep the y, and it's the top exponent minus the bottom exponent, so 5 minus 5. The next one is x, because they're the same base, to the 6 minus 3 power. So if we simplify that, we can get 2y to the 0, x cubed. Now we know y to the 0 is just 1, right? So 2 times 1 is just 2. So we get 2x cubed as our final simplified answer. Y to the 0 is just 1, so 2 times 1 is 2. And 2 times x cubed just gives us 2x cubed. Okay, so looking at 7 now, we have 72y over 9x to the negative 5th power. So since x is to the negative 5th power and in the denominator, what we can do is we can write it in the numerator. So we're getting that 8 from dividing 72 by 9. 72 by 9, if you have your calculator with you, is 8. 72 divided by 9 is 8. And since x to the negative 5th is in the denominator, we can move it to the numerator. So we have 8x to the 5th y. That's as simplified as we can get it, so we can leave it like that. For number 8, we have 2 to the negative 3 power over x to the 5th, y to the negative 7th. Once again, y to the negative 7 is in the denominator. And we know by following our generalized rule that y to the negative 7th in the denominator is the same as just y to the 7th in the numerator. Now 2 to the negative 3 is in the numerator, which again, remember guys, is the top part of a fraction, and we can move that to the denominator. So here we just kind of do some switching around because of the negative exponents and where they're at. So we have y to the 7th over 2 cubed x to the 5th. Okay. Now, if we simplify here, all we did to get to that second step to the third step, y to the 7th, we didn't change anything. 2 cubed is just 8. We know that. So we have y to the 7th over 8x to the 5th. Y to the 7th over 8x to the 5th. So all we did there was take that 2 cubed, because we're trying to simplify it as much as we can here. And that's all we did. 2 cubed is 8. At number 9, we have x to the 5th y minus 3. X to the 5th y minus 3 over x to the negative 2 y to the negative 8. Now remember our rules for dividing exponents with the same base. We just subtract them, right? So that's all we're doing here. We're writing x to the 5th minus, because we subtract those exponents. 5 minus negative 2. Now this is where I know a lot of us have been struggling in the previous semester. 5 minus negative 2. You have to have 2 subtraction signs there, guys. There has to be 2. You can't just lose one. And y to the negative 3 minus negative 8. Y to the negative 3 minus negative 8. Now, we know that 2 subtraction signs next to each other can change to addition. So this would simplify to x to the 7th, y to the 5th. So 5 plus 2 is 7, and negative 3 plus 8 is a positive 5. So we would get x to the 7th, y to the 5th. Okay, and that is it for section 8.3.